taking us this course, programming using Java language. This class is going to be divided into 2 series. I'm going to start with the system programming.
Mr. Adegoke, please share your screen.
I believe you are seeing my screen.
Please share your screen.
So the first thing is I've done that. Can you see my screen? I've done. Exactly. Hello. Can you screen?
Yes, we can see your screen. Continue.
Okay. All right. So, intro to system programming and programming using Java. Let me just give us a brief introduction to this class, in as much as a few minutes of our time has been spent due to these technical issues. However, we're still on course. System programming. Let me just give us a general overview of this course before we move on. System programming, we'll be looking at the word system. What do we mean, and what do we mean by to know about system programming? Now, after looked at that, we also move on to look at Java programming. Now, Java programming has to do with, as a matter of fact, is the most stable and most compact programming compared to Fortran, compared to even C++, because the fact that Java programming is also an independent program, which means it can run on its own. Java program can run on its own, unlike other programs to be run inside a machine. That is sort of your Java program in in a browser. So let's move on. What is a system? Is a set of independent. What do we system program? System software. That is, when you write a software, that is system programming. And system programming is the science of designing and constructing translators. System programming involves designing and writing computer programs that allows the computer hardware. I need you to underline that and note it very well. It's a computer that allows the computer hardware to interface with the programmer and the user, leading to the effective execution of application software on the computer system. Now, this particular definition is more of a broadened definition of a system programming compared to the first two that I've introduced to you. Now, what we are saying here is that when it's made up of the hardware, okay, and then you have what we call the software, allows this hardware to be able to communicate and interact with each other. And then the third party here is the user. Okay, the user is the person that now comes to make use of this computer such a way that the hardware interact. All right. So what system program, it allows the hardware. It is the software, the program, the system program allows the hardware to be able to communicate with the programmer and then the user. And this will now be effective execution software on the computer. It's even used and firmware. Programming tools such as compilers, assemblers, input I/O routines, which is input output routines, interpreters, schedulers, loaders and linkers, as well as the runtime libraries of the computer programming languages. So we are saying here is that what you basically be exposed to could be, apart from in the types of the hardware, is the operating system or and the application software. But here we are talking about compilers, assemblers, interpreters, and the rest. These are another level of programming that allows machine language that works what we call the machine language, and this allows the machine, which is the hardware, to be able to communicate with each other and then to be able to understand the programs at which the application software and the system software is going to run on them. Now let's look at the system program and the application program. I want to believe we are all familiar with the application program itself. Number one, difference. It says system program. It is a collection of components and heart or designing of a given program. While application software or application program rather is a set of programs that view computer as a tool for solving a particular problem. Says system program is a collection of components and heart or designing of a given program, while application program is a set of programs that view computer as a tool for solving a problem. What we are saying here is that while application programs allows you to be able to view your computer to say, oh, this is my computer, I can be able to use it to solve a particular problem. In a system program is a collection of components that allows for the design of a particular program. So that means you must have your system program allows even you to be able to develop an application program to be able to solve a particular problem. Point two, programming is done using assembly language, which interacts with hardware. Note that programming is done using assembly language, which interacts with hardware. Application program. This application program is used to build application software, which includes software. In essence, this shows the basic difference in how system program and application program runs. This is point two. What we are saying here is that system program allows the hardware to be able to interact with each other, and that is done using what we call the assembly language. Okay, while the application program is used to build the application software, which are the software that we use to solve particular task. It could be basically office tasks. Point three here, system software that executes the application software. System software enables you to be able to execute the application software. Application software is a software that are used by the end user. Are we getting that now? While the system software enables the use of application software, the application software itself is now being used by the end user, which is you and I. The machine makes use of the system program, you and I makes use of the application software or program. Point four, System programming is used to write low-level instructions. Low-level instructions. Application programming is used to write high-level instructions. Okay, high-level instructions. Now, what are the examples of system program, which is point 5? We have the loader, we have the linker, we have the compiler, and the rest. In application program, we have the library management, the system, the calculator, the web browser, and so on. So let's look at the application program itself. An application program is a comprehensive, self-contained program that performs a particular function directly for the user. Just like we said in that difference, that the application software allows you to be able to perform a particular function or solve a particular problem which is being used by the user. It is any program designed to perform a specific function directly for the user, or in some cases for another application program. So let's look at the various application program. This includes email, web browsers, games, word processors, enterprise software, accounting software, graphic software, media players, database management, and so on, like that. Now let's go into deep of the system software. And the first thing here, we'll be looking at the assemblers. Assemblers. An assembler is usually understood to be a translator which produces machine language code as output from an input language which is similar in structure to the output. The natural symbolic units of the assembly language or input correspond to the natural units of the computer for which the assembly is intended. What are we saying here? Let me explain it line by line. An assembler is usually understood to be a translator, okay, which produces machine language code as output from an input language which is similar in structure to the output. What we are saying here is that there is an input and there is an output. So what an assembly language does is that it produces a machine language from an input which is being received, and this input has a similar structure to the output. Okay, and then the natural symbolic units of the assembly language or input will now correspond to the natural units of the computer to which the assembly is intended. So that means whatever device, the way the language is going to be written will be in such a way that it's going to allow the assembly language function properly. Translator. A device which transforms an output string B. A translator is a device which transforms an input string A into an output string B. There's another one is called compilation, or we can also call it compiler. Compilation is a process the computer takes to convert a high-level program language, such as COBOL or Fortran, into a machine language that the computer can understand. So the software which performs conversion is called a compiler. What we mean by a compiler or a compilation is that the transformation or the conversion of a high-level program language, which a typical example is COBOL or Fortran, are examples of high-level language. It now transform them or convert those languages into the machine language. Don't forget that in system programming, we are talking about ability for the machine to be able to communicate with each other. So for the machines to communicate with each other, they need a language. There's a language that's is going to be developed for the machines to be able to communicate. So that language that the machine understands, just like you and I, the language that we understand, either Yoruba language, Igbo language, Hausa language, or English language, the language that we understand helps us to be able to communicate with each other very well and effectively. So you could imagine if I speak French and then you speak English, there's no way we can communicate with each other effectively. Okay? Except we now get somebody who we call an interpreter. Okay? That will now interpret from English to French, from French to English. Okay, so that's what we are saying here now, that we need to be able to convert that high-level program language to a low-level language, which is the machine language, so that the machine will be able to communicate with each other. This is what we call the interpreter. An interpreter is a language translator whose primary task during translation is to perform the actions dictated by the meaning of the statements of the language. In more concrete terms, what we mean is that interpreters read and obey the statements of languages. So basically, what the interpreter does is that they interpret and read they read the statements of. When the compiler compares the high-level languages language, interpreter send us what language. We have the simulation of real computers, simulation of hypothetical computers, interpretive compilers, simulation languages, and then the monitor system. Okay. So as we end the class for this evening, let's look at the difference between interpreter and compiler. They may seem familiar, so are they not doing the same thing? Are they not observing the same function? So let's look at interpreter. Number one, it says translates program from one statement translates one program from one statement at a time. Compiler will scan the entire program and translate it as a whole into a machine code. What I mean is that while interpreter does a step-by-step statement conversion, the compiler will combine all the data or information or programs together and then translate it at once into a machine code or a machine language. Okay, that means while interpreter does step-by-step statement conversion, compiler does a batch conversion. 2, it takes less amount of time to analyze the source code, but the overall execution time is slower. Whereas in compiler, it takes large amount of time to analyze the source code, but the overall execution time is comparatively faster. What we are saying here is that we've said that the first point that the interpreter takes it step by step to interpret. That means that in the process of doing it step by step, the amount of time it uses to analyze the source code is less compared to the one that we have to harness them in bulk and then begin to analyze one after the other, which takes longer time. However, that is in the short run. In the long run, the time to now execute, the time to analyze is short, but the time of execution for interpreter now takes a longer time, while the time of execution for compiler takes a shorter time. That's why it is faster. Third point, no intermediate object code is generated, hence are memory efficient. No intermediate object code is generated, hence memory efficient. For the compiler, it generates intermediate object code, which further requires linking and hence requires more memory. What we say is that interpreter requires less more memory because intermediate object code are not generated. So it saves memory, it doesn't require large size of memory. But for compilers, the way it works, it has to generate an object code intermittently, and this will now require you to create a linking, which requires more memory. So that means a compiler requires more memory because of the process that it has to go through. Fourth point, interpreter continues translating the program until the first error is met, in which case it stops, hence debugging is easy. For compiler, it generates the error message only after scanning the whole program. Hence, debugging is comparatively hard. What we are saying here is this: while the interpreter will translate the program, and once it sees the first error, it starts debugging to know where the error took place and what went wrong, and then be able to correct it. And that's what we mean by debugging, is to be able to analyze and know why did this error happen, how should we correct it and move on. But in compiler, it will have run all the program before you now start detecting error messages. And with that, debugging becomes hard because you now have to go back to the first point where error message shows and then begin to correct and start coming down and start coming down and start coming down. So it becomes complex, sort of, and that's one of the reasons why it also requires a higher memory compared to interpreter. Programming language like Python, Ruby uses interpreters, while programming languages like C, C++ use compilers. Okay, so those are the programming languages that use these two types of system programming. Do I have any question from students? Are there questions? Hello? Any question?
Mr. Adegoke, you're still online. Oh. Hello, Mr. Adegoke. Hello, students. If you have any question, please unmute your self. Just look for this mic symbol on your screen and tap it. You'll be able to talk. We'll be able to hear you. Thank you.
There are basically two types of tables. We have the ordered tables, we have the unordered tables. What is unordered tables? The easiest way to organize a table is to add elements as they appear without any attempt at ordering. The easiest way to organize a table is to add elements as they appear without any attempt at ordering. That means as the data comes, you just pile them up. You just arrange them like that in that order as they come. But when it comes about to other tables, another table is one in which an ordering relation which is greater than or less than exists between any pair of arguments of the table, and two, if SI represents the ith element of the table, then for all j's, SI is greater than S. And three, if and only if I is greater than J or SI is less than S, then J if only I is less than J. What we are saying here is that there is a condition. This condition will determine how these arguments are going to be placed on the tables to ensure that things are arranged in a particular order. So those three conditions will determine the order at which those arguments will be arranged as they come. Okay? The table is then ordered in ascending or descending sequence. So you can determine to the program to set the program to do the table ordering in an ascending or descending order or sequence. Utility software. Utility software is a system software designed to help analyze, configure, optimize, or maintain a computer. A utility software is a system software that is designed to help analyze, configure, optimize, or maintain a computer. It is used to support the computer infrastructure in contrast to application software, which is aimed at daily performing tasks that benefit ordinary users. What we are saying here is that while an application software is a software that is able to be able to complete or perform a particular task or solve a particular problem, the utility software enhances the functionality of a computer system. It enhances the functionality of its computer system. It optimizes the computer system. It improves the configuration of the computer system. A simple example of an utility software is an antivirus. An antivirus is an utility software which enhances the security performance or the security features of this CD burning software. Naturally, you should be able to burn your files on your CD or DVD, okay, with your CD-ROM application on your system. But by the time you install a CD drive burner like Nero and the rest, it enhances the functionality of what you can burn, what files you can burn, how you can burn that files, and every other functions that your ordinary system cannot perform when it is burning files or copying or writing files to CD or DVD. Okay, so that is what utility software. They enhance the functionality and the performance of your system. So typically, a utility software is smaller than the program in size and may be included with an operating system or installed separately. So most times you get them installed separately. So the ones that usually are included with the operating system are usually the antivirus. Sometimes you discover that when you buy a new system, you will see McAfee comes with it pre-installed. You see Norton antivirus comes with it pre-installed. You see sometimes Capacity comes with it pre-installed. Those are utility software that comes together with the operating system. while some of them you will have to install it separately and individually. So what are the list of computer utilities as a round of this? We have just 2 minutes. Examples of computer utility software: backup software, keyboard, compression utility, cryptography software. We have debuggers, we have DirectX, we have the disk checkers, which is used to defragment or do disk cleanup or to scan your disk, that's your hard disk. We also have the disk partition editors and the rest like that. All these are essential utility softwares. Okay, it's Dr. Watson encryption tool, encryption manager, X memory network monitors, page manager, registry cleaners, screwsaver, and system monitors. These are various. I'll sign off right now. It's already 8 o'clock, so we'll meet in the next class. So the take home I'll be giving you, which I expect from you next class, is go and read more on system programming and ask me basic questions on system programming. Very much. Don't forget that you are compulsory.